Welcome back to Boiler Wild. My name is Eric Johnson. I have a good one for you today. Hopefully you enjoy it. It is going back to the basics of basics, but as we hopefully all know, the basics are not basic. And if you don't talk about the basics and you assume that everybody knows them, then you end up not learning the basics. But first, I want to talk about the ratings of Boiler Wild. If you have, in the kindness of your heart, could you please rate on the podcast app right now while I'm talking about it, while you're thinking about it? 5 stars, whether you're listening on Apple or Spotify. That would do me a big solid. That basically just tells the platform that this podcast is in existence and people do listen to it. And those ratings help my podcast get found by other people that are searching for it and not get lost in the millions and millions of podcasts. Not that any of those platforms would ever recommend this podcast to people, but it helps when searching because I have found that, and if you're not well aware of colleges, but Purdue University out of Indiana is the Boilermakers, and they have a ton of podcasts, and a lot of them have boiler in the name. So when you search Boilers podcasts, essentially, a lot of Purdue University podcasts come up. So rating this podcast would do me a solid and just help get the word out, because I do put a lot of work into this podcast to hopefully make it valuable for you and for others. And I want as many people to hear it as possible that need to hear it. I know boilers are a niche of a niche, and the listenership for this podcast is always going to be pretty small compared to other podcasts. And I don't really do this to get rich and famous off podcasting. If that was a thing, I definitely would have not choose to talk about boilers to do that, because I don't think anybody gets rich and famous off boilers. I'm in it for love of the game, and hopefully you are too. If you are new to boilers, hang with it. They're not as scary as you think. They can be exciting. You can have some long days working around with boilers. You can see people do a lot of stupid stuff. You will do stupid stuff. I have done stupid stuff, but you need to learn from your mistakes and hopefully get better. And before you know it, you'll be the one that every company is vying to hire, and you'll be out there providing solutions for customers, however that looks like. If you don't already know, Boiler Wild, you may be wondering, Wild, that's a weird name. It's a acronym I came up with. It stands for work hard, invest yourself, lead others, and develop yourself into a person of excellence. I always believe that we should always want to get better. I always want to get better at work and at home, and you should too. And by listening to this podcast, you're getting better. If you're driving in the morning, I've been there, I've done that, driving 2 hours to a service call or to go visit a customer site. Or if you're just driving into the office, I do appreciate the office folks as well. Or you are on a ship, or if you're listening on a plane, I appreciate wherever you're listening. Let me know where you're listening. And if you last thing on the housekeeping side, if you do find this podcast episode or any other episodes valuable, please tell somebody about this podcast. I would greatly appreciate it. Get the word out there. There are millions and millions of options for podcasts for people to listen to, and I am doing my best to make something that's valuable for anybody that is in and around boilers, combustion, industrial burners, ovens, furnaces, all that kinds of stuff. Today's topic, I have titled this podcast, Let the Fire Triangle Guide You Home. And this is a core knowledge piece that you need to know in order to be successful working around burners and boilers and having a general understanding of how combustion works. But the fire triangle is what needs to be your guiding light when you are troubleshooting a issue that is intermittent, or you can't get a fire in the boiler, or the burner doesn't want to light, or you don't have a stable flame. Go back to the fire triangle. And so many people skip over the fire triangle and just start getting lost in all the details. Go back to the basics. Go back to the fire triangle. Now, what is the fire triangle? So it can also be called like the combustion triangle, fire triangle. I'm going to call it the fire triangle. It is 3 parts you need to have combustion, a flame, let's say. And if you didn't already know, triangle has 3 sides. So think about a triangle, and at each point you will have one of these things. Point 1 is oxygen. Point 2 is heat. Point 3 is fuel. So point 1 is oxygen. And typically with boilers, when you are burning a fuel, you are going to consume air, which is atmospheric air, which contains oxygen. The atmosphere, if you're just to go outside on a normal day, the atmosphere is about like 79% nitrogen and 21% oxygen. And then there's a bunch of little gases that are a tiny fractional percentages outside of that. But if you turn on your combustion analyzer, you will hopefully see when it calibrates a 20.9% oxygen reading, and that is because that is the atmospheric oxygen reading, and that is normal, and that is where that oxygen is coming from. So while we are consuming or burning the oxygen, it's essentially where you can't see the oxygen in the air. So when a combustion air fan blows air into the front of the burner where the combustion process takes place, there's going to be air particles, which are going to be nitrogen and other tiny percents of other things that are actually not in the combustion process. And so point 2 is heat. And you may be wondering, heat, how does that relate? So heat let's back up. Combustion is a chemical reaction. And without going deep into chemistry, combustion is essentially flammable vapor burning. And when you remove the heat, you are cooling the vapors below the ignition point of the vapors. And you may be thinking, well, I burn wood. Wood isn't a vapor. Combustion happens in the gas state. And if you were to take a lighter, so you light a lighter and you're actually burning the butane, there's no liquid coming out, but it is liquid in the canister, but you're burning the vapors from that fuel, and then you hold your lighter against a piece of wood, and that wood doesn't just combust. Like, let's say we have a stick. That stick doesn't just burst into flames, but if you constantly hold it there, it will slowly start smoldering, and then it may start producing some like visible white smoke. And essentially you have to add enough heat to the wood to get it above the ignition point to where it will release the vapors that end up burning. And that is why it is so hard to start a fire. But once you have a fire going and you have a very, very hot fire, you can throw a log into it and that log starts burning because there is so much heat that can be added to the log so quickly that it can produce those vapors and then start burning. That is a very simple explanation for that, but you have to just remember that combustion happens in the vapor phase, not the solid phase. Then you say, well, how does gas burn? Well, gas, as in like gasoline, is one, it's very flammable. It has a very low ignition point for producing vapors, and the actual fuel, gasoline, the liquid gasoline, when you light gasoline, the liquid does not light. It is the vapors that are evaporating off the liquid that lights. And then once you have it lit, there is enough heat that you can end up quickly evaporating the rest of the liquid, which evaporates into a vapor and can cause a large explosion. If you control it, you can run a combustion engine. That's essentially what happens inside a combustion engine. Or injectors inject gasoline, liquid gasoline. It sprays it in. Your spark plugs produce a spark, and it causes a mini explosion in the cylinder. That explosion pushes down the piston, and that is essentially how your engine turns a rod or output shaft into your transmission that makes the energy from the liquid gasoline turn into physical energy or rotational energy. The third point is fuel. So if you've ever tried to light water on fire, you will find it very, very frustrating. But if you light a dry leaf on fire, it will light very quickly, because you have to have a fuel that is flammable. And once again, that it basically, there's different levels. There's stuff that's flammable, which produces gases below 100 degrees. So gasoline is flammable. And then there's combustible fuels, which produce gases above 100 degrees. Diesel is combustible. So if you have a spill of diesel on the floor and you throw a match on it, the match is just going to go out. But if you have a spill of gasoline on the floor and you throw a match on it, the match is going to light because of that difference. And that is because the diesel has a higher temperature at which it produces combustible vapors. I believe it's around 125 degrees, and gasoline is around 45 degrees. That is also going into like the flash point. That's essentially what that is flash point, as when it gives off enough vapor in order to ignite. But let's just talk about it in a very simple manner. So let's say we have a candle. We set the candle on the table and we go to light the candle. We light the candle. The wick is lit and the fire's burning, and you put a glass jar over the top of the candle. The fire slowly keeps burning, and then it slowly dims, and then the fire extinguishes. And what happened was the fire, the combustion process, remember we have a triangle. So we had a fuel, which is the wick, and we had enough heat, which is the fire. We weren't removing heat from the fire, so we had enough heat to maintain that fire on that wick. And then the jar, since it didn't allow any air to get to the fire outside of what was in the jar, the fire consumed all the oxygen in the jar. And once all the oxygen disappeared, the fire is going to go out. So we removed oxygen from the triangle. Now let's remove heat. So you can easily remove heat by throwing water on a fire. That removes heat. You can also remove heat. There's videos out there. So if you light a candle and you take a copper coil, that's just room temperature, and you put a copper coil that's tightly coiled around, say, like a pencil, and pull out the pencil, and you lower that coil over a fire, that copper coil is going to conduct the heat away from that fire on the candle, and the fire is going to go out. You didn't restrict the oxygen, and the fuel is still there. The wick is still there, but you removed the heat component from it, and now the combustion process is going to stop. Now, with a candle, the easiest one to see is removing the fuel component. So if you try to light a candle and you don't have a wick, or you light a candle and you let it burn a couple hours and the wick burns all the way down, and you get to the bottom of the candle and you only have wax left but no wick, the fire goes out because there's no candle wick left to burn. It runs out of combustible material, and now the fire goes out. So that is a very, very small fire. Now let's think about it in a bigger sense inside of a boiler. So a boiler has typically a main flame and a pilot. Especially larger boilers, that is not always a thing. On smaller boilers, you can do direct ignition, but let's talk about the boilers that go from pilot to main ignition. So what happens in a boiler? So let's say Scotch Marine boiler, gun style burner, and just typical normal process. So what is the sequence operation? So we're going to have pre-purge period, and the pre-purge period turns on the combustion air fan and blows fresh air, which the 20.9 oxygen and the 79% or whatever nitrogen into the combustion chamber of the boiler. And we're going to make sure that we don't have any vapors or leftover fuel that is going to ignite rapidly. We want a safe space in order to start the ignition process. So pre-purge, so we're blowing all fresh air. So now we have fresh air in the environment. So that is going to check off one side of the triangle. We have fresh air. So now after pre-purge, we're going to go to pilot. So the air damper or VFD ramp down, and we don't need as much air to light off pilot. We need to have a very small amount of air. If we just have the fan wide open, we're going to have way too much. It's going to cool off the ignition and not allow a flame to establish. So we're going to close the air damper. We're going to slow down the fan, go to the pilot. How do we light pilot? Typically, we light pilot, and this is a burner that's burning on natural gas. So we're going to light pilot with a ignition transformer. The ignition transformer produces a spark. That spark is the initial heat that is going to start the combustion process. That spark, well, it may not seem like it, is hot, and that is going to ignite the vapors of the natural gas. It is already in the vapor state, but it is going to ignite the vapors of the natural gas. And since the fan is running, we're putting in air, which is the oxygen, and now we have the ignition process. And when everything is balanced and controlled, we can hold pilot for 10 seconds typically. We're going to approve pilot, and then we're going to go to main. And main flame is just a larger flame, but it pulls the heat. Once again, we're going to have the fuel, which is going to be from our main fuel valves. We're going to have the air from our air damper and our combustion air fan that is blowing in. And then the heat is going to be coming from the pilot flame. And as the main fuel valves open, the pilot flame is going to ignite the gas coming from the main fuel valves, and we're going to ignite the main flame, and then the pilot will shut off, and now we have flame inside of the boiler. That process depends on that fire triangle. Now what happens if we close a valve on the gas train. So we close the valve on the gas train. We are now removing the fuel portion of the combustion triangle, and the fire is going to go out and you're going to go down on flame failure. But what if we turn off the combustion air fan motor, or we close the air damper? If we slowly start closing the air damper, you are going to starve the fire from oxygen, and it's going to try to keep burning. Fire wants to burn, so it's going to try to keep burning. It's going to end up producing soot because you're not producing a clean mixture essentially through the combustion process. But you essentially then turn off the combustion air damper, combustion air fan. You starve the burner of oxygen, and you're not producing or giving any more air to the flame, and the flame will go out. And then the heat part is, if you, this is a little different for every single burner, but essentially you have to radiate heat back to the flame, and the burner tile does a good job of doing that, where when the burner tile heats up, it can radiate heat back to the flame and help keep the flame going and the combustion process going. The metal around the combustion process also helps to radiate it back at the flame. If you were to take the heat away and like quench it with water, or if you were to turn up the fan, so if you were on pilot and you just put the air damper wide open, you would have too much air and it would be cooling the fire, and it would not allow the combustion process to happen. That same thing happens essentially when you have a candle and you blow it out. You are blowing oxygen or air onto the fire. So why would the fire not keep going? It's because you are blowing too much and you are removing the heat from the fuel, and essentially that will cool the vapors below the ignition point of the fuel, which will make the fire go out. Now, hopefully that makes sense. Hopefully you've all lit a fire at some point and experienced lighting a fire at a campsite or something like that, and the frustration of trying to light a fire. In my experience, when you want to light a fire, it's never easy, but when you don't want to light a fire, like inside an office building, everything seems to light up very easily. But if you're out in the middle of the woods and you have wet fuel, you can't light a fire because the water is constantly taking the heat away from the fuel and not allowing the fuel to create the vapors in order to produce a flame. But if you have a flame already and you have a large fire, you can throw a wet log in the fire, and since you have enough heat, that log all the water will turn into steam, and now all the water has evaporated and it will dry the log out, and now the log can heat up and it will produce flammable vapors and then start burning. Fire triangle, what is the importance of it? So when you're troubleshooting and you can't get the burner to light, or you have pilot issues, go back to the fire triangle. One of the most common problems with a fire triangle is intermittent pilot flame failure, and you'll go there. The pilot will light and then it will go out. And people will say, clean the flame scanner and do this and do that. None of that matters. You watch the pilot light and then you watch it go out. What part of the fire triangle do we have too much of? We probably have gas. You always want to check your gas, which is going to be your fuel. In this case, whenever I'm talking about the boiler, I'm talking about a natural gas boiler. I mean, I guess I can also talk about a liquid fuel such as number two fuel oil, but you have the gas and you have pilot. So the pilot valve's open and everything's working there. So you know your fuel is correct, your fuel pressure is correct. And you look at your spark, you look at your electrode or your igniter, and you check the gap, and everything's good there, everything's good sparking, but the flame keeps going out. Well, you're like, well, the blower's on. Why? It's adding oxygen. Well, it's actually cooling the flame too much, and it's not allowing the combustion process to start. So you actually have to remove air and to essentially allow that heat, the one part of the combustion triangle, you have to allow the heat to be there in order for the combustion process to start. Now, with a liquid fuel, such as number two fuel oil, it is the same exact thing. The fire triangle still applies. So when you want to go burn a liquid fuel, let's say we have a smaller burner that is direct ignition. So we go through the pre-purge process. We want to make sure that we don't have any flammable vapors inside of our combustion chamber. And now, instead of going to pilot, since we don't have a pilot, we are direct ignition. We're going to go down to the ignition point, which is going to be typically low fire. So the air damper is going to close down. The fuel is going to be at the low fire position, the fuel valve for the number two fuel oil. Your ignition transformer is going to come on. Typically for number two fuel oil, your ignition transformer is going to be 10,000 volts. So your ignition transformer is going to come on, create the heat from that spark. That spark is what the heat is, and going to start the ignition process, but that spark is not going to sustain the ignition process, but it's just going to start the ignition process. So the spark, which is the heat, so we have air, our combustion air fan is running, we have fuel, our number two fuel oil valves open, and we are atomizing it so that we can burn it correctly. Atomizing a fuel means that we are putting it into little droplets, which increases the surface area of the fuel, which is essential in order to burn it. If you were to try to burn, think of number two fuel oil, which is essentially diesel. Think of it in a bucket. If you had it in a bucket and you just threw it up in the air, emptying the bucket, and you tried to burn that, there's only so much surface area. But think if you pressurized it and you pumped it through a nozzle and you atomize that fuel, so now that all that fuel inside that bucket just becomes a mist, now you've greatly increased the surface area, which will allow it to create more flammable vapor to ignite and burn in the combustion process. So your fuel valve is open, your 10,000 volt transformer is going, and you have heat from the spark, you have fuel from your pump. We are going to be pumping in the number two fuel oil and atomizing it through the oil nozzle, and then we have our air from our combustion air fan, and that is going to start the combustion process. And then after 10 seconds or so, the combustion process will become self-sustaining because it produces enough heat to constantly reignite the added fuel that we keep adding to the fire, so that we no longer need the spark to add the heat component. So the spark will stop. We are still pumping in fuel, and since we already have heat, which is the fire, the combustion process produces heat. That heat ends up making a cycle where it will constantly keep reigniting the fuel as we keep adding it. And then, of course, the combustion air fan is still blowing at this time. And now we have the combustion process inside the boiler, and we are burning number 2 fuel oil. So that is essentially how the fire triangle goes. If you were to stop atomizing the fuel oil and you had burner issues and you had the combustion air fan going and you had your spark correct and your igniters all set up correctly, but you didn't atomize the fuel correctly, you don't have enough surface area in order for the fuel to produce flammable vapors in order to ignite. And that is what is happening there. If you don't have the ignition or the spark, the heat, and if you just have your combustion air fan and the fuel getting pumped into the boiler, now you don't have any heat, and it's just going to alarm after 10 seconds because you didn't add any heat to the process. However, if you have a very, very, very hot boiler and you were to pump fuel into it that is atomized, and the hot metal of the boiler can heat up the vapors of that fuel above the ignition point, you could start the combustion process. And that is actually how I blew a burner off the front of a boiler. It wasn't my fault. I think I told this story before, but the customer lied to me, did all this stuff. I don't want to tell the story again if I already told it, but customer lied to me, and the supply and return lines for the oil gun were backwards. So essentially during the entire pre-purge process, it was dumping fuel into the boiler, and when it went to ignition, it essentially lit the vapors inside the boiler because I had a hot boiler, and the ignition process started also from the spark. So from the spark in the hot boiler, it ended up lighting all the vapors from the fuel that was laying in the bottom of the Morrison tube and blew the stack off the boiler, ripped the whole burner, the center of the burner out, reconfigured the burner, bulged all the doors popped open, but the actual sheet of the fire side on the doors bulged out. I was lucky wearing FR, but I did get burned on my neck and my wrists, which were exposed because I was standing right in front of the boiler. It wasn't my fault though. The customer told me that they light fuel oil once a month, and I was just there checking combustion, and they ended up lying, and the customer did all their own PMs and service, and they had ended up putting the supply and return valves backwards. But the other story I want to tell you about this, about the fire triangle and getting overwhelmed, is I was sitting at home one day years ago, and it was a Saturday, I believe, and get a call, hey, so-and-so is having trouble with this boiler. It won't light. They've tried everything. So I talked to so-and-so, and they're going on and on about this, going on about that, this, that, and they've gone over everything. They've gone over the basics. They have great spark. They have pilot, but they can't get main flame to light in the boiler. Scotch Marine boiler, just normal gun style burner, Honeywell 7800 flame safety, standard gas train, natural gas, steam boiler. And so I go, and I knew what the boiler was. I've been there to that location plenty of times. And so I went and swung by an office, one of our office headquarters, and picked up a used part and drove to the customer site, which was an hour and a half away. Got there. This person that was on site, they were deep in it. They had forgotten the combustion triangle, and they were checking everything. They were checking all the safeties. Why can't this? Why can't that work? This, jumping everything out. Like this boiler won't light. And so I got there and pressed reset, and boiler did the typical thing, went through pre-purge, went to ignition, lit the pilot. Flame signal was 5.0, so that's perfect on a Honeywell 7800, and went through 10 seconds, and then went to main ignition and failed after main ignition. And I had watched the fuel valves try to open, and they were older ITT hydro motors, and one of them was ASCO solenoid valve, and the other one was a older hydro motor. And if you don't know, the actuator for this gas valve is hydraulic driven, and if it loses hydraulic pressure, it won't be able to overcome the spring pressure of the actual valve body. So I watched the indicator of that gas valve actuator, and it barely cracked open. It started moving, but it had barely cracked the valve open by the time the main fuel trial for ignition period ended and the boiler locked out. So now, knowing what we know about the fire triangle, I immediately knew what the problem was. The person on site had seen the actuator move, and they assumed that was not the problem. Well, if you don't know, typically most actuators will open within 3 to 6 seconds. A lot of them will be rated at 6 seconds, but open within like 3 seconds to full open. And these are just standard on-off actuators. And you only have 10 seconds to light the gas, the main ignition gas. So if it takes 3 seconds for the valve to open, which is going to be your full gas, which you need in order to produce a stable flame, and you only have 10 seconds, that only allows you like 6 or so seconds to establish the actual flame once all the gas is now available. So it's a pretty tight window if that actuator starts lagging and not opening the valve fast enough. So I put on this used actuator that we had because this actuator and valve was obsolete, and this used actuator that I had brought, that I knew was the problem, fixed the problem, and the difference was night and day. The actuator opened within like 2 seconds. Main fuel lit perfectly. Boiler went off to the races, and we are having steam pressure again. The combustion triangle, the fire triangle. So we had air. So the air damper was working great. The fan was going the right way. So we had the proper amount of air. We had air or oxygen being put into the boiler. We had ignition. The igniter was perfect. The pilot assembly was perfect. The pilot was lighting, so we knew that the igniter assembly was working, so it wasn't like the ignition transformer. A pilot not lighting is different than main gas not lighting. So what is the other part of that is the fuel. Do we actually have main gas fuel going to the combustion area or to the burner head? And the answer in that was no. While we may have had some fuel because the actuator was barely opening, it was moving, but it was barely opening at the end of the 10 seconds. We did not have enough to balance out the fire triangle and to have the proper mix for combustion or a fire to start. So we didn't have enough fuel, and the fire didn't start. And once I put on the new used actuator that worked correctly, the proper amount of gas was delivered, and the fire was able to start. So that is a good representation of the fire triangle and the basics not being basic, and you easily not thinking about the basics, and it must be something bigger because my gas valve is moving, so I must have gas. That same thing can essentially also be done with rags in the gas train or blockages in the gas train. I have not experienced this, but there have been blockages in new boiler gas trains, or people put a rag in a gas train for whatever reason, and they will watch their fuel valves open. The air will be on, all that will be fine, and they'll have great spark, or pilot will light correctly, and they'll be like, man, I can't get main gas. Well, you don't have fuel in the triangle, so you're not going to get a fire. If you don't have fuel, you don't have your triangle completed, so you're not going to get a fire. So just because your main gas valves are moving and you see the actuators moving doesn't mean you actually have gas going through those valves. In that case, if you have a blockage like a rag upstream, or if you have the improper pressure, or if you have your butterfly control valve set wrong and you don't have the right amount of fuel going to the combustion area, the burner head, you will not get a flame. So it is balancing those out. You need to keep the balance, but you always want to remember the fire triangle. Hopefully I explained that correctly. It's still a challenge for me on this podcast to explain things without any visual references. All I can use is my words to describe things, which is very not natural for me. But that is why I started this podcast. If you listen to the couple first episodes, I explained that of the reason for starting this podcast is essentially becoming a better communicator and being able to communicate ideas more effectively to you, the listener, which I greatly value and appreciate. So next time you have an issue with pilot not lighting or main flame not lighting or any kind of issue like that where you cannot sustain combustion, go back to the basics, go back to the fire triangle. Do I have heat? Which at the start of it is spark. Do I have fuel? And actually make sure you have fuel, not, the actuator moved, I must have fuel. Do you have fuel and enough of it? And do you have oxygen? And that's typically the easiest one, although sometimes you can have too much air and blow out the fire by removing the heat away from it and it not being sustainable. That is all I have today. That is all I want to talk about, the fire triangle. If you learned anything from this podcast, thank you. If you said, or if you thought I said anything wrong, please let me know. I'm doing my best to describe things correctly, scientifically correct. That is not my strong suit in order to describe things scientifically correct off the top of my head in a verbal manner. I love to use pictures and draw things out, but let me know. I'm always open to criticism and corrections if I said anything wrong, but the one thing I do know is the fire triangle will guide you home and allow you to be successful when other people are not. So if you enjoyed this podcast or you enjoyed other podcasts, please rate this podcast 5 stars, tell somebody about it, and stay wild.